friends, welcome back to my YouTube channel Classroom Mania. First of all, happy Independence Day to all of you. So this is the fifth part of the chapter motion. If you haven't gone through the previous parts, then links are available below in my description box. Go and check it out. So let's start today's class. So today we are going to study about circular motion in brief. We have already discussed about different types of motion. Now let's recall it once again. So what is circular motion? When any object moves in a circular way with respect to time and surrounding, that is known as circular motion. So what is circular motion? When an object moves in a circular way with respect to time and surrounding. Then the object is said to be in circular motion. Now the question is how to calculate speed of an object if it's moving in a circular motion. Suppose a car is moving in a circular motion and it completed one rotation. Now what is the speed of the car then? So we know speed is equals to distance by time. So if the car has covered one rotation, that means we have to find the circumference of the circle. So distance covered is equal to circumference of the circle. So V is equals to 2 pi r by t. So if the car has completed 2 rotation, means it will be multiplied by 2. If 3 rotation, it will be multiplied by 3. And if half a rotation, then it will be multiplied by 1 by 2. In this way, we can find the speed of any object moving in a circular manner. Now we will see the graphical representation of motion. For that, we will need a copy and a pen. So we will leave this board and go to there. Now we will study about the graphical representation of motion. In this, we will study about two types of graphs. First is distance time graph. The change in the position of an object with time can be represented in this distance time graph. So this is our x-axis and this is our y-axis. Remember one thing, x-axis is always represented by time and here y-axis is represented by distance. So this is our graph in which x-axis is represented by time in second and y-axis is represented by distance in meter. So according to this graph, in first 5 seconds, the object covered 10 meters. In 10 seconds, the object covered 20 meters. In 15 seconds, the object covered 30 meters and so on. So joining all these points, we got a straight line. This is a graph for uniform speed because the object is covering 10 meters in each 5 seconds. So it is covering equal distance in equal interval of time. And in uniform speed, we will always get a straight line, a graph of a straight line. From this graph, we can also calculate the speed. How? Now let's see that. Now let's take a small part AB from this distance time graph. What we have to do now? We have to draw a parallel line to x-axis from point A and the same from point B. So the parallel line to x-axis from point A is DC and from point B is BE. Now from origin to point A, the distance is S1 and from origin to point B, the distance is S2. Similarly, from origin to point A, time taken is T1 and to point B is T2. Now to calculate the speed, we have to find distance by time. So here we have to find the total distance traveled by the object from point A to point B. As we know, at point A the distance is s1 and point B the distance is s2. So we have to calculate the distance from this that we have named as ED. From this graph, as you can see, EO is equals to ED plus DO. We already know the value of EO, that is the distance from point O to point B, that is S2. Now ED is what we have to find, and from point O to D we know already the distance is S1. So ED is equals to S2 minus S1. So we have found the total distance required. Then we have to find the total time taken. Similarly, we have to find the time from A to time from B. So time at A is T1, time at B is T2. So from this graph we can see OG is equals to OF plus FG. So OG is equal to T2 and OF is equal to T1. So and we have to find FG. So T2 minus T1 is equals to FG. Substituting this in the formula, V is equals to D by T. So here D is S2 minus S1 and T is T2 minus T1. So speed is equals to S2 minus S1 by T2 minus T1. In this way, we can calculate the speed from this distance time graph. Let's see another type of distance time graph. So this is the graph in which x-axis is represented by time in second and y-axis is represented by distance in meter. So according to this graph, we can see the object covered 5 meters in 1 second, 10 meters in 2 seconds, 17 meters in 3 seconds and 30 meters in 4 seconds. So according to this graph, as we can see, the object is covering unequal distance in equal interval of time. That is, the object is covering unequal distance in each 1 second of time. So this is a graph representing non-uniform speed. One more type of graph is there, that is this. This is x-axis, this is y-axis, and this is time in second, and this is distance in meter. So according to this graph, in first 5 minutes the object is at 20 meter. In 10 seconds the object is at 20 meter. 15 seconds the object is at 20 meter, and so on. So we can see the object in every 5 minutes, the object in every 5 seconds, the object is in 20 meter. That means the object is not moving, the object is stationary. So this is a graph where the line is parallel to x-axis. That means the object is not moving. Now let's move on to the second type of graph, that is velocity time graph. So as you can see, this is x-axis which represents time in second, and this is y-axis which represents velocity in meter per second. So as we can see in this graph, in first 5 seconds the velocity is 30 meter per second. In 10 seconds the velocity is 30 meter per second. In 20 seconds the velocity is 30 meter per second, and we can see the velocity remains constant. Joining all these points, we get a parallel line to the x-axis. So we will always get a straight line parallel to x-axis for a uniform velocity. This is a graph for a uniform velocity where the velocity remains constant, where the velocity is same at any time. We also got a parallel line to x-axis here. So in this place, in distance time graph, when we get a parallel line to x-axis, that means the object here is not moving. But in a velocity time graph, if we get a parallel line to the x-axis, that means it is in uniform velocity. We can also calculate the magnitude of displacement with the help of this graph. How? Let's see it. So this is a velocity time graph where we have taken a small part AB, and the velocity at point A is v and velocity of point B is also v, because velocity here is constant. Now the time at point A is t1 from the origin and time at B is t2 from the origin. We have named it as D and C. Now as we know, we have to find the displacement. So the formula for velocity is equals to displacement by time. So displacement is equals to velocity into time. So now we have to calculate the velocity and time. As we know, velocity here is constant, so let's take it as v. Now we have to calculate t. From the picture we can see that OC is equals to OD plus DC. We have to calculate the time from A to B, right? So OC is equals to OD plus DC. AB is equals to DC, right? AD is equals to BC. AB is equals to DC. So this is equivalent to this and this is equivalent to this. So now we will find this DC. So OC is equals to OD plus DC. We know the value of OC, that is T2, and OD is T1. So DC is equals to T2 minus T1. Now we will put this value here. So displacement is equals to velocity into time, that is V into T2 minus T1. For V we can write AD because this is equivalent to this. So we write AD, and in place of T2 minus T1 we write DC. So we multiplied this side into this side, which is equal to the area of rectangle ABCD. So in this way we can find the displacement. This is another type of velocity time graph where the x-axis represents time in second and y-axis represents velocity in meter per second. As you can see, in first 5 seconds the velocity is 10 meter per second, in 10 seconds the velocity is 20 meter per second, in 15 seconds the velocity is 30 meter per second, and so on. Joining all these lines we get a straight line. As you can see here, in every 5 seconds the velocity is increases by 10. So here it is, the velocity is increasing in a uniform way, that is equal amount of velocity is increasing in equal interval of time. So this is a graph for uniform acceleration. For all uniform accelerated motion, the velocity time graph is a straight line. So this always, for uniform acceleration we will get a straight line. We can also find the distance moved by an object from this graph. Now let's see how. This is the velocity time graph which shows uniform acceleration, and we have taken a small part AE from that. Now we have to calculate the distance covered. So the initial velocity at point A is u and the velocity at point E is v. Time at A is t1 from the origin and time at E is t2 from the origin. Now we will draw parallel line from point A and point E to this x-axis. So we drew these lines. Now we will join all these lines and name it as A, this is B, C, D, E. So we got this A, B, C, D, E. And distance travelled is equal to this area A, B, C, D, E, which is a trapezium. So now we have to find the area of this trapezium in order to find the distance travelled by the object. So S is equals to area of A, B, C, D, E, which is equal to the area of this rectangle plus area of this triangle, which is equal to area of rectangle ABCD plus area of triangle ADE. Now area of this rectangle is equals to AB into BC, and area of this triangle is equals to half into base, that is AD, into height, that is ED. Now we will put the values here. AB is equals to U because this is equivalent to this. So AB is equals to U. Now what is BC now? As we can see from the diagram, OC is equals to OB plus BC. OC is equals to OB plus BC. As we know the value of OC, that is T2, and OB is T1. So we put it here. T2 is equals to T1 plus BC. This means BC is equals to T2 minus T1. So we'll put it here, U into T2 minus T1 plus half into AD is equivalent to BC. So This is also T2 minus T1. Now we have to find ED. As we can see, EC is equals to ED plus DC. EC is equals to ED plus DC. So as we know, the value of EC is V and ED we have to find, and DC is U. So V is equals to ED plus U. This implies ED is equals to V minus U. So we put it V minus U. In this way, we can find the distance in this graph. Here, two more types of velocity time graph are given. In the first graph, as you can see, initially the velocity is high and then in the final stage the velocity is low. That is, U is greater than V. As we have already studied, when U is greater than V, that means initial velocity is greater than final velocity. This will result to negative acceleration, and negative acceleration is known as retardation. So this is a graph for retardation, that too a uniform retardation. Remember one thing always, whenever the term uniform comes, that means the graph will always be a straight line. So this is a graph for uniform retardation. In the second graph, as we can see, in 5 seconds the velocity is 20, in 10 seconds the velocity is 30, in 15 seconds the velocity is 20, in 20 seconds the velocity is 50. Joining all these lines, we get a line that is in zigzag manner, not uniform. So this is a graph for non-uniform acceleration. With this, let's end our today's class. We will meet in the next class with the same chapter and the last topic of this chapter.